Compañeros, welcome to the SQL Data Partners podcast, the podcast dedicated to SQL Server related topics, which is designed to help you become familiar with what's out there, how you might use those features or ideas on how you might apply them in your environments. I am Carlos L. Chacon.
And I am Steve Stedman. We are two data professionals trying to help others get a better handle on their database environments, either through this podcast, our training, or our consulting practice. Thanks for joining us on the SQL Trail. Welcome to the show.
SQL Data Partners.
Okay, in this episode 75, we have Argenis Fernandez with us. He is an architect or a consultant with Pure Storage. And when you get an email from Argenis saying, hey, there's something else I want to talk about, the answer is, of course. We'd love to have you back on. We got great reviews when he was on with us in an earlier episode. And he's back again to talk with us a little bit more. So the focus of our today's conversation is what you would do in order to ensure that you can test your SAN storage, kind of make sure that you're hitting all of the components, maybe some of the gotchas, and then ways to ensure that you can hit the metrics and how to keep the SAN vendors or your disk vendors on the hook until you reach those metrics.
You know, this is a very interesting topic, Carlos. I know that I've been tasked with working with different clients where you were just assigned the SAN storage. Somebody came in, went in and did the configuration and just said, here you go. And you're given a server configuration, and it's not always optimal for the SQL Server environment. And oftentimes at that point, it's too late to go back and make changes. And I think that some of the things that Argenis has to say about testing it and keeping that vendor on the hook are really important, not just from the SAN administrator, but from the SQL DBA side as well.
No, exactly. And I think having that information and at least knowing what boxes to check or what questions to ask will help people down the road to ensure they have a good setup.
Yep. And I wish I had the information from this podcast 2 years ago. It would have made life much easier on a few projects, I'll tell you that.
No, that's right.
Yeah.
And of course, with Argenis, we get into it, fairly quickly and lots of good information for him. And so we're glad that he can make it out to the podcast again. We do, however, have a couple of folks that are talking to us.
Yep. This week, we received a comment from Patrick Flynn. Patrick's someone I know. He participated originally in the Database Corruption Challenge in my presentation at Past Summit this year. But what Patrick had to say about the podcast was that he's enjoying the longer, more in-depth approach, and he's particularly enjoyed the Linux episode. And he said, this was the first episode that I listened to more than once. Thanks for your work.
Yeah, so thanks, Patrick, for listening and for the comment. We appreciate that. And that Linux episode was very interesting and I think is going to be a game changer for a lot of folks.
Yep, and that was, about a month ago we did that one?
That's right.
Yep. So keep in mind, we're always interested in hearing feedback, whether it is good or bad. Fortunately, we receive more good, but whatever you've got to tell us, feel free to share it with the Twitter hashtag of SQL Podcast, or send us a message, or there's a way on the SQL Data Partners website to leave us a recorded message. And if you leave one of those, you've got a chance of us playing it on one of our future episodes.
That's right. The show notes for today's episode will be available at SQLDataPartners.com/storage testing. Of course, all one word. So storage testing. And with that, let's go ahead and get into the interview with Argenis. Argenis, again, welcome back to the podcast.
Thank you so much for having me again, you guys. It's always awesome. I actually requested this one, so I'll be upfront with everyone in the audience. I did tell you guys to please go ahead and schedule me again because I wanted to go on yet another rant. Like I went on one rant on the previous one. I'm ready to go on another one, man. Let's go.
Very good. And as you all know, compañeros, what Argenis wants, Argenis gets. And of course, we're happy to have him back here on the show today. So last time we talked, it was kind of just an SSD conversation, talking a little bit about disks. Today, our topics might be wide in range, but we want us to kind of kick off potentially with testing your disks that you're using in your servers.
So storage, testing, and validation, right? Which is actually something that we end up doing as DBAs. Like a lot of times we're basically told, yeah, you need to go verify that array. We're doing this POC, we're testing this new storage. You need to go ahead and test it, right? Mm-hmm. And what is it? You guys answer this for me. What's your favorite tool to use when validating storage?
They've deprecated SQLIO, so Diskspeed is the other one that comes to mind there.
Ding, 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 right? So that's what everyone looks for. So SQLIO, I love SQLIO, and rest in peace now, because it was completely wrong name to use, like quite possibly the most awful name to use for that tool, because it actually had nothing to do with SQL Server whatsoever.
Exactly.
It just so happens that somebody on the SQL team wrote that utility, but it was actually never meant to validate SQL Server patterns, right? It was just a storage benchmarking tool, basically, right? It wasn't even good for baselining because you couldn't take like one, I guess you could save the outputs and then compare them to some other output that you took in the future, right? To see how you were doing, etc.
Exactly.
But you don't see those things on SQL Server like that, right? So for example, you would get all these fancy scripts from people out there, that would run SQLIO at multiple block sizes and multiple threads, and you would get some numbers, and and what's funny is that us as DBAs, we would actually never know if that was good or not. We'll be like, yeah, we got some numbers. They look all right. Let's go. Right.
Sure.
So that's actually kind of funny, right? Because at least that was my experience way back when I was given, I can't remember who the manufacturer of that array was. And I was basically told, here, you go test this stuff. I was like, okay, what do I do? So naturally I found SQLIO, and then SQLIO test this stuff. I was like, okay, what do I do? So naturally, I found SQLIO, and then SQLIO is what I ran, and I got a whole bunch of numbers, and I got a bunch of pretty graphs, and then I show them to the storage guy, and the storage guy's like, yeah. Like, okay, what does that mean? Is that good? Is that bad? Are we, if I put my databases on this thing, are they going to work? Or, what is it? So on the era of magnetic storage, and this is changing super fast, like way faster than any of us expected. As you guys know, I work with flash arrays all the time, so I'm not really motivated or particularly interested in validating storage on magnetic anymore. But back in the day when we had the old HDD comprised arrays, magnetic arrays or spinning rust or whatever you want to call them, we wanted to test using something that made sense, right? So SQLIO would be a thing, right? Because it would actually generate some workload against the array, and regardless of the fact that it will be a pattern data set to real data set, right? Not even close. At that point, whatever performance characteristics you would see on your storage array at that point, you will be happy with. Right, because you would basically ask the storage guy, hey, I'm getting, 800 megs a second on that thing. Is that good? The storage guy would be like, yep, that's good. All right, I'm done. Right? I validated that my performance was okay. You will look at the latency and see if the latency will be acceptable at different block sizes, and you would commit the most frequent mistake of all, which would be tying your allocation unit size on NTFS to the actual block size that gave you the best latency, right? That's what everyone would do.
Right.
Like you would actually make that mistake right there and then. You would go ahead and see what SQLIO told you in terms of latency for a given IO block size. And you would say, yep, I need to format my volume at this particular allocation unit size because that's what's going to give me the best performance. That couldn't be any farther from the truth. Like literally, I have no idea why people got stuck on that. On that myth, and I actually have a blog post that I'm sure we can reference from the podcast here that mentions this. IO block sizes and SQL Server in general.
Well, now, so Argenis, just to be a knuckle dragger here, right? Because everybody knows that. So isn't that because I've just run this test? It's telling me, hey, this is the allocation unit size that you should be using, and then you're like, okay, well that's what I'll go and set that up with.
That's what the test is telling you. The test is telling you that at a given IO block size, your storage array behaved in a certain way. The IO block size, as you well know, has nothing to do with the actual allocation unit size that NTFS uses. They're two completely different things. So it makes no sense for you. So if you got the lowest latency at 4K, consider 4, right? And so larger allocation units sizes, so 64K and quite possibly larger than that with newer file systems like Refus, which is becoming a thing nowadays, you would not consider using smaller allocation unit sizes because you want less metadata for your file system, as long as that metadata doesn't become a contention point for allocations.
Right.
And this should not be a contention point because this doesn't work like PFS, GAM, and SCAM pages, right? You're not going to be continuously allocating new extents for your database all the time, like one by one, right? This doesn't become a contention point for your database in terms of growth.
Yeah, so then with that, I mean, it used to be that you look at SQLIO and then you format your partition size on your disk to match whatever your best throughput is. And then came along the rule that general always format it with 64K block size. Yep.
You just go 64K. Yeah, that's what you should do. That's what you should do. There are other storage arrays that still tell you to format at a different allocation
with 64K block size. Yep.
You just go 64K. Yeah, that's what you should do. That's what you should do. There are other storage arrays that still tell you to format at a different allocation unit size. I literally have no idea why they ask you to do that. Because I don't know. I don't even know if these people are guided by the same things that I'm mentioning here, or they're just looking at the completely wrong thing, right? At my company, we just told everyone, format at 64K, you'll be fine. You're just going to perform just fine. Other storage array vendors tell their customers to go 4K on transaction log and go 64K on data files. I have no idea why they say that. I don't have no idea how they're architected at that granular level that it actually matters. To me, it shouldn't matter on any storage array for the most part. Now, would you see differences on SQLIO? Yes, because you're allocating a file up front for SQLIO. That's one of the things that matter, right? Like SQLIO actually takes time to allocate that file, and Diskspeed does that thing as well. So were we actually swayed by the fact that SQLIO was creating a file, or what? I think that's actually part of the problem.
Other examples that might include is if I'm moving or upgrading from one server to the other, I already have a larger file and I have to allocate all of that space, right? In the case of a growth, right, I start with a very small database and then I'm growing in chunks. Those patterns are also different.
Well, I mean, at that point, you need to start thinking in terms of file system, right? So you have a set of database files that are sitting on a given file system. If you're migrating a database from one server to the other, and you're just using a restore, that destination file system doesn't have to match the allocation unit of the source file system by any means, right? If you're using something like storage vMotion or storage live migration on Hyper-V or whatever it's called on the Microsoft world, you would just migrate something and that would end up with that same allocation unit size because you're performing basically a blob, doing things, et cetera, et cetera. But what matters in the end is, but me personally, ask your storage vendor what is it that they like. If they like 64K, ask. It will probably be safe to end the conversation right there and format at 64K. If they ask you to format at 4K, ask them why. Why is that a thing, right? Are they doing the right thing by telling you to format at 4K? Anyway, rant over on that one, guys. Let's not go into that. Let's take a step back. We started talking about SQLIO, right? And we said, rest in peace. It had the wrong name to begin with. It generates pattern data. It was replaced by Diskspeed. But guess what? I love Diskspeed, and I kind of hate Diskspeed at the same time. Because you know what Diskspeed does? It also generates pattern data. Why does that matter? Most of the storage arrays that they sell today, pretty much every single one out there, has intelligence built into the controllers. So whenever you send a pattern data. Why does that matter? Most of the storage arrays that they sell today, pretty much every single one out there, has intelligence built into the controllers. So whenever you send a pattern data set to it, it will basically just mark a little metadata entry for it and nothing else. So you actually wouldn't be stressing. This is actually super important for everyone to understand. You would not be stressing your final media. So if you're pushing data down to hard drives, you wouldn't be stressing them. If you're pushing data down to SSDs, you wouldn't be stressing those either, because the controllers will basically drop all that data at the head, so at the front end. And it will basically just say, yep, I got some activity going on here, but it wasn't enough to merit me using the SSDs or the hard drives at all.
Yep.
That's kind of very important, right?
So then in that case, then Diskspeed may still be good for testing like local drives that are installed.
However, if you have something like, I don't know, like Storage Spaces Direct or whatever that might have some other backend behind the scenes, you still have to go through all of that, right? You may have an intelligent controller on the other side that may be managing this for you. You don't know that, right? As a DBA, you're not told exactly how your storage stack is laid out.
Sure.
Right? So if you're connected to some storage array, they're not giving you the specifics of whether that stuff is doing something a certain way or not. So your job as a DBA is to make sure that you test with the best data set possible and the best workload possible. So is Diskspeed the thing that's going to generate the most realistic workload for you and the most realistic data set for you? I think the answer to that is a flat, resounding no.
Right.
So this is why I only use Diskspeed to validate plumbing, meaning I'm getting good throughput. So this is why I only use Diskspeed to validate plumbing, meaning I'm getting good throughput. I'm getting good latency really quick, right? My channel is good. I have a good line of communication between my host and my storage. That's all I'm testing with Diskspeed. If you have an old-fashioned, you're just a dumb SSD, for example, that you just directly attached to a server, and you want to run Diskspeed against that, yeah, that's good. But is that actually going to test everything on that SSD? I will dare say no, because there's more to that. An SSD is actually comprised of NAND, right? Like NAND chips. And the NAND chips actually perform garbage collection, right? So overall, the SSD has a controller, and that controller would decide at some point to perform garbage collection on that NAND, because NAND is not byte addressable. Okay, NAND is actually addressed kind of like database pages, right? Like the entire pages are written at the time. You don't write on a byte-by-byte basis. So that actually makes a huge difference, right? When you're testing at something that's byte addressable, like a regular like a regular hard drive used to be, that will be byte addressable, right? Like sector addressable. You wouldn't trigger garbage collection on an HDD because there was no need for that. But on an SSD, you will trigger garbage collection. And the only way to stress an SSD so that you make sure that you trigger garbage collection on it is by priming it, so filling it with data, and start writing data to it again. So you will trigger the garbage collection mechanisms. Okay. So did you see how storage testing is a complex story? It's not something that's straightforward. It's not just running Diskspeed and seeing what kind of numbers do I get. It's so much more than that. So much more than that. It's running a continuous workload at different I/O block sizes with a given reducibility of the data. Actually, that we haven't even talked about this. Reducibility of the data is a thing on all flash array. Right, like ours does, right? Like the other company that I work for does it. EMCs does it. SolidFire does it. Nimble Storage does it. Tegile does it. Everyone does compression, right? So when you want to validate that all of those storage arrays are doing the things that you want, they're going to reflect a certain performance characteristics upon a given workload in a given data set. You want to test with the real workload and the real data set. So again, Diskspeed doesn't take you there. Diskspeed only helps you to test the plumbing to make sure that, whatever is between you and your final storage device is not bottlenecked somewhere. It is really good for that. And it's really good for testing dumb byte addressable storage. But here's the other thing that a lot of people don't know. Diskspeed actually has a way to generate random data sets. You can tell Diskspeed, here, go ahead and generate a random buffer. But getting it to work, there's actually a huge bug on Diskspeed. It actually has a way to generate random data sets. You can tell Diskspeed, here, go ahead and generate a random buffer. But getting it to work, there's actually a huge bug on Diskspeed. Getting it to work, it's actually really complicated. I don't even remember exactly all the conditions that you have to do. Like, you have to use a file of a certain size, and then the buffer that you pick has to be evenly divisible by the size of the file, or something like that. I can't remember what it was. It's just a series, because it's buggy and it's not quite perfect. Then you have to have all these conditions for it to generate a random workload. But then that random workload will be so random that wouldn't actually be representative of your real data set either.
Sure.
So it would be like the complete opposite of what I said before, right? You could start with a pattern data set, which is very easy for the controller to drop, right? And on the complete opposite end of the spectrum, you're sending a completely garbled high entropy data set that makes no sense whatsoever, and it's not actually reflecting your real workload. This is why I keep telling people storage array is going to do the things you want it to do. And you can see how it reacts, right? And to your workload, and keep it on a continuous loop, right? So run it over and over and over. Increase the frequency of your workload if you can. So there's multiple ways, and we can talk about that. Multiple things that you can do to kind of replay your workload and kick off more threads and stress the storage array a little bit. Or if you can't do that, there's synthetic testing that you can do against the storage array that will kind of mimic database access patterns, but it wouldn't be your real workload. In the end, what I want people to do is forget about running Diskspeed. Forget about running the SQLIO. If you want, run Diskspeed really quick just to make sure that you got good connectivity against your storage array. But in the end, what you want is to replay your production data, your production data set, so restore your production data set and replay your production workload against that storage array. That's really what's going to give you the best picture.
At that point, when you say replay your queries, replay your workload, at that point, when you say replay your queries, replay your workload, I assume you're talking about the distributed replay controller at that point then.
That's one way of doing it, right? You also have Orca, which is another way of doing it. There's other tools out there that, from vendors that allow you to do that. I believe Quest Software has one, if I'm not mistaken. There's
what
others,
was that
right?
second tool you mentioned?
I'm mentioning three that I've just mentioned three that I know about. And even if you don't have time to do that, you can just run an ETL, right? Which most people have an ETL, or you can write a very intensive read queries or write queries, provided that you do things called cache, right? So you flush your buffer pool with DBCC drop clean buffers, then run your queries or your IO intensive queries against a restored copy of your database, and see what kind of behavior you see, right? But more importantly, when you're testing and validating a shared storage array, it's not one workload that's gonna be hitting that storage array. So things get even more complicated, right? This is why, I could be talking about this stuff literally for weeks, right?
Well, even then, Argenis, right? If you just flushed the buffer cache, but that's on the database server. I mean, you mentioned even so the caching at the SAN level. Now, it's the first time you pull that, it's not going to be in that cache. But how do you?
Exactly. Well, that's another thing, right? If you have caches on the SAN side, how do you invalidate those caches, right? If you're going to have a cache on your SAN, do you want to use all that cache for writes, or do you want to use all that cache for reads? It depends on your workload.
Sure.
So what I tell people is, what kind of workload do you have? If you have a data warehouse, there are going to be times during the day when you do ETL and you load data into that data warehouse, that you want to have that cache to be used for writes as much as possible, right? And then at some point, you're going to start querying that database, and at that point, that cache better be used for reads in a way, right? So it really does. And this is why working with your system engineers from your storage vendor matters a whole lot. You need to understand, what knobs are available to you, or even if you want to tweak them or not.
Sure.
But when you're validating a storage array, it's very important that you understand that there's a cache or not. So ask that question from your storage guy. Hey, is there a cache involved in this thing? Because if there is a cache, you want to make sure that you do enough testing that you overrun that cache and see what the behavior will be after you overrun that cache and you start operating at a different speed. Because that's something that the storage people love to do. They love to abstract you from the fact that you're running on slow storage by throwing another tier of storage in there. Is that solving the problem? Maybe, right? Maybe it does fix your problem for you, but is it a long-term solution for your workload that's continuously growing and continuously getting more aggressive? Maybe not.
Well, it's the old adage. I mean, it's just the new version.
Fix your problem for you, but is it a long-term solution for your workload that's continuously growing and continuously getting more aggressive? Maybe not.
Well, it's the old adage. I mean, it's just the new version of throwing more CPU and memory at the server.
Right. And so tiers are a thing, right? For storage, that have always been a thing. And even at the CPU level, you have different kinds of caches, right? You have an L1, an L2, and an L3 cache for instructions on and data on the CPUs. So this is not a new concept, right? By any means. It's just that, how many times do you have to change your storage so you can get a solution going which is also a very big thing, right? How many times do I have to migrate my database before we actually run on a thing that actually supports my workload? It's a pretty common problem out there, right? Like a lot of people here in this podcast will probably identify themselves with this. I migrated my database once because we switched to new storage. 6 months into it, we realized that it sucked, and now we have to migrate it again. So using that storage array the right way, that you're making the right purchasing decisions. It's very important, and going back to this point that I was talking about before, the reducibility of the workload is very much a thing, right? If you just create one database that's completely empty, and what are you testing there, right? You just created a database that's completely empty. What are you testing there? Absolutely nothing, right? If you're validate the performance characteristics of a TDE encrypted database that you're placing on an array that performs deduplication, compression, and things like that are going to be different than if you send a database that's in the clear, right? So that doesn't use any compression whatsoever. The performance characteristics will be different. So you want to validate both. You want to make sure that your array reacts a certain way for your data set. So if you have TDE encrypted databases, make sure that you restore TDE encrypted databases to that array, and you run your performance tests on top of that. Because the future is filled with arrays that perform data reduction all the time, everywhere. And even if your array only offers certain features, and you're going to use some of those features, like for example, there's some arrays out there that have data services turned off, but you can pick to do compression only, for example. Then make sure that you enable compression on the volumes, the volumes that you're going to use for your databases, and drop your data in there in whatever final form is going to be. So if you place compressed data on top of an already compressed data set on a compressed volume, on a volume that will perform compression, what kind of performance characteristics are you going to see out of that? In general, it can be kind of eye-opening to see how storage arrays react to different data sets. A lot of people don't think about this because they just think that running a quick Diskspeed will get them out of the way.
Over new storage that's shared, and you start out with SQL Server there, and everything's running great, and then over time, the SAN administrator decides to load that storage up with additional systems using it. It's a bunch of backups right in there, or file stores, or other systems using it. One of the things that I've seen when this happens is that your SQL Server performance degrades over time. And I guess as far as testing that, one of the things I'm really curious about is how do you kind of test on a regular basis to know that your production performance is not degrading there on the actual I/O side of the storage?
Well, so you nailed it, right? When you mentioned that this happens very frequently, and that's just because people are not doing their homework, right? Every single storage array has limits. There's a given amount of workload that you can fit on it at first, and it works just fine. As you add more workloads into that array, you start seeing different performance characteristics from that array as you're adding different workloads with different patterns, right? That's just natural. And if all of a sudden you start, you have your data warehouse running at full throttle on that array, you start adding a bunch of VMs that are going to do, I don't know, you're running Exchange on those or whatever, or SharePoint or whatever, you're going to see a different kind of behavior from that storage array. So how do you test that? The only way to test it that you can be comfortable with is mimicking what it's actually going to be, as much as possible. And as much work as that takes and as painful as that sounds is the only way to make sure that your storage array is performing a certain way. So take your real workloads with your real data sets and hit your array with that. If you want to fit an additional workload and you don't even know what that workload looks like, then you do have some homework to do, right? Like you need to understand what are your current, how busy your storage device is, and whether it will accept your workload, and you don't even know what that workload looks like, then you do have some homework to do, right? Like you need to understand what are your current, how busy your storage device is, and whether it will accept that additional workload without tipping it over. Will it actually cause it to, start generating a lot more latency, or would your throughput be reduced because of that additional workload? Because now you have, everyone's drinking. And, we had a big fire hose before. Now we have two people that are drinking from it and not just one, right? It kind of works like that. It's just a device. Every single computing element in your data center has limits, and the storage array or your storage devices are just one more. So you need to understand what those limits are, and when you're going to fit more workloads into that, you need to make sure that you do your homework and understand how busy that storage device is. And when you are ready to drop that new workload in, that it fits nicely and it's not gonna tip it over.
Like repeatability, automation, right? That's like the big mantra, and it almost sounds like, hold the presses here. There are certain areas where, not that you can't automate all of it, but at least you're going to have to understand. You're going to have to do some homework first, and then choose your own adventure, if you will.
No, you nailed it, right? That's exactly what happens. And you know what? A lot of people think that they can get away with not doing this in the cloud. Oh, it's just a cloud, so it's fine. Oh, it's not fine, all right? Let me tell you. In the cloud, you have a bunch of, Amazon may not tell you, Microsoft may not tell you, Google may not tell you, but they do all these things that we talked about, right? So they do the caching, the tiers, and they have this devices on the behind the scenes that do a whole lot more than just storage, right? So they might actually have data services involved in all that. So it's not as straightforward to test storage on the cloud either.
Yeah.
What I like to do is just tell people, remember the basics. You could get some idea what the throughput and what the latency would be like using this. We're using kind of dumb, synthetic tools like Diskspeed or Iometer, or I don't know, the Crystal Disk Mark, which in the end uses Diskspeed underneath the hood, or Atto or whatever. There's like 100 of them, right? You could definitely use those, right? They'll give you an idea. But testing with real workload and real data sets is going to be the thing. This is why I get people. I literally have a friend who was pinging me on Twitter the other day. They bought this hyperconverged solution. It looked great when they ran SQLIO and Diskspeed against it, but guess what that thing was doing? The exact same thing that I mentioned before, right? It was dropping the patterns at the controller side. So they never actually saw it perform with real workloads on real data sets because they didn't test the fundamentals, which is test with your real workloads and the real data sets. I keep hearing about hyperconverged, by the way. It's a thing now, like everyone's talking about hyperconverged. I need to remind people that hyperconverged is great, but not necessarily for databases. So one big problem with databases is that they need low latency. You're going to be doing transaction log writes. You're going to be doing a lot of reads, and those reads better be performed quick, right? Because the quick turnaround from storage is the thing that's going to give you the better performance.
So I've been hiding under a rock, Argenis. Describe to me what hyperconvergence is, or hyperconvergence.
So hyperconvergence is it's kind of a term that's in vogue now for describing a new kind of architecture where compute and storage is all the same thing, and even networking is it's kind of hidden. So you can do on your same compute nodes, you can have storage now for describing a new kind of architecture where compute and storage is all the same thing, and even networking is it's kind of hidden. So you can do on your same compute nodes, you can have storage attached to them, and everything is kind of flat, and it gives you like that kind of cloud experience when it comes to provisioning storage kind of thing. But in the end, you're sharing resources between storage node and compute nodes.
Sure.
So you can end up with a situation where your databases are running on the same exact node as your storage device, and your storage, the actual serving of the storage, takes compute resources, and those compute resources are being kind of colliding with your databases. So there's obviously other kinds of designs or features on hyperconverged where you can have storage-only nodes, but that's really no different than having your own storage device out there. Right? So they're basically splitting storage again into its own node, because it's basically having less things to configure on your network. So it's more like the appliance approach to computing, where you just buy something, hook it up to your network, and 2 seconds after you have it up and running. Well, provisioning is part of it, right? Provisioning and getting things to run fast is one part of it, of course. But it's the ongoing operation and the ongoing performance that you're going to need out of that thing that really matters a whole lot. So if you're looking at hyperconverged solutions, please, please, please make sure you test with the right tools. And if I can mention one synthetic tool that actually works really, really well, and I personally hate Oracle, but this is one thing that comes from Oracle that's kind of decent. It's called VD Bench. VD Bench. So Victor David Bench. A better idea of how your workload and how your data set are going to behave on whatever storage device you're testing. Because it actually allows you to specify deduplication and compression settings for your workload. So you can say, oh, this is like a database, so it will dedupe 1.2 to 1, and it will compress 2 to 1, or it will compress 5 to 1. Or I'm testing VDI, so I'm going to have a lot of reducibility on my workload. It's going to reduce 19 to 1, so I can test it that way. And then you can also generate workloads by saying, I have, this kind of IO block sizes at this time of day. I have these peaks and valleys, and you may actually specify that the target device needs to be filled with data before it actually can be tested. So it's got a whole bunch of sweet features that you will love to leverage when testing and validating your storage.
Okay, great. So
data before it actually can be tested. So it's got a whole bunch of sweet features that you will love to leverage when testing and validating your storage.
Okay, great. So one of the questions I have here is that it seems like when we talk about testing with an actual real workload, that really that oftentimes in my experience happens after someone's already made the decision on purchasing your storage, and it gets into the environment and here's what you have, figure out how to best use it. I mean, is there a process that you generally go through in the pre-sales when people are looking at different storage where you can do this kind of testing usually?
So most of the storage vendors out there will want you to perform a POC. Some of them actually don't like it because it takes resources away from them, right? Like, they have to ship you an array and they have to be on top of you, and you only have so many days to complete that POC,
right?
Etc. Most of the storage array vendors or the storage vendors in general, not just storage array, they will happily give you something for you to try. And it's during that period that you're able to validate that storage array. The storage device. If your storage vendor does not do that, and your management was sold on that storage array, and you get it right away, I need to remind you that most things you can actually return. So if you get something, test it right away. Like, drop everything you're doing and test it. Because you don't want to pay for this in the long run, especially if you're the DBA who's going to be babysitting processes that are going to be running on top of this thing. Because imagine you end up with a dud. Imagine you end up with a storage array that's not going to give you the performance you need, or storage device is not going to give you the performance you need. You're going to pay for that dearly. You're going to pay for that with your weekends. You're going to be suffering. You're going to have just make sure that you test things as much as possible, that you inject yourself in the process of acquiring storage as much as possible, that you become knowledgeable on the storage side as much as possible, because storage is a thing that is fundamental to every database out there.
Right.
Like, every single database is backed by some sort of storage. And if you don't understand how that storage works, and you don't get into it a little bit, even a little bit, then you're going to pay for it down the run.
And I think that's where, if you're working in a shop where there's a wall that's been built between the storage administrators and the DBAs, that's where you get in the most trouble. But when they're the same person doing both sides of it, or that there's no wall and there's very good communication between the DBAs and the storage admins, then you're able to make those kind of things happen.
This is something that you have to foment, right? You have to make sure that whatever walls exist in your environment today, you can overcome. Like, you become best friends with the storage people. You know exactly what they have. The storage people know why you care about certain things. They understand why databases are the pain in the butt that they are for storage. They are a pain in the butt, right? Like, the storage people hate DBAs for a reason, because the databases are nasty. Especially, take backups, right? Who has a storage guy that loves to see the performance of the storage array when taking backups? Nobody, right? Because backups are just nasty on every single thing. Backups are nasty on the source storage array, backups are nasty on the network, and backups are nasty on the target storage array. So or JBoF or whatever. It may not be an array, but whatever you end up backing up to. So it's a thing. Like, people need to understand that if you don't talk to the people that work in your company that do different things than you do, then in the end have power and oversee the things that matter so much to you, you're just hurting yourself. And that's actually part. We could go on another rant about why you should be best friends with your developers as well. But it's basically the same thing, right? Like, everyone is working toward the same objective, which is making sure that your company continues to operate at the highest level, and you can crank out features and crank out new functionality as fast as your business wants. So don't become an obstacle right there. That's actually something that I advocate to everyone. Don't become an obstacle on the database side. Don't become an obstacle on the storage side. Don't become an obstacle on the virtualization side. Offer solutions. Tell people, hey, this isn't working. Let's go see what we can do to make it better. Right? And engage more people and make sure that everyone understands what's actually going on in your environment. Because the last thing that anyone wants is surprises. Oh, we never told anyone that this actually wasn't working.
Right.
You need to make sure that everyone knows what's the status of your environment out there.
Yep.
It sounds like very good career advice.
Absolutely.
It sounds like very good career advice.
Absolutely.
Yeah.
So we
all right, you guys. So, man, we went on a little rant over there.
Oh, it's all good stuff.
My breath here.
Well, thanks again for being with us today, Argenis.
Hey, it's my pleasure. Thanks for the time, you guys. I really, really, really wanted to do this because, I want to make sure that people kind of got a taste of what it's like to pay so much attention to the little details on the storage side. A lot of us have been kind of complacent in the past and said, oh, I just got some storage array some storage device that I got from this guy. I'm just going to quickly run something and numbers look good. I'm moving on. That's not it. It's so much more to it. So you need to understand how things work and why testing in a different way matters so much.
That's right. So before we let you go, we've had you on the show, so we've done our SQL family questions with you already. But we do, I guess, for those who may not know all of your history, give us...
Remember when Google came out, I was like, oh, I'm not using Yahoo anymore. Or I'm not using AltaVista anymore, or whatever we were using back then. That felt awesome. Now, I remember I was SQL Server 6.5 that I was powering the backend for this product that I was working on. I was working for an ISP down in Venezuela, an internet service provider, the largest one down in Venezuela. And the mandate was to migrate from a FreeBSD environment to a Windows NT4.0 environment. So you guys can imagine, right? Like that was really, really, really controversial. So we got a lot of pushback in there. But in the end, that was the mandate that came from management. And we purchased this product from Microsoft called Microsoft Commercial Internet System. It's called MSys, right? And the version of that product was version 2.0. So that server was that suite of products was NT4.0 with the option pack. So it's called right, and the version of that product was version 2.0. So that server was that suite of products was NT4.0 with the option pack, so IIS and all of that. And you had an additional set of binaries for running an SMTP server, a POP server, an LDAP server, and that LDAP server was powered by Site Server's Commerce Edition, Site Server 3.0. So if you guys have, like really ancient folks like me that worked with the technology way back when, you remember all of this stuff. And actually, I can't remember if it was Site Server 3.0 or an earlier version on the first version of MSys that I used. I can't remember. The truth is that it was powered by SQL Server 6.5 at first, and then they developed support for SQL Server 7.0. So that's kind of how I got started with it, maintaining that database, and I was basically there were many of us, accidental DBAs for that database. That's kind of how I got started with it. And so so that was January of 1999 when we came here to Redmond for the first time. We spent a month here training on that product, and we were basically given, a crash course on Windows administration and SQL Server administration. So that's how I got started with SQL way back when, and, changed jobs 100 different times, and, made my way through I did sysadmin for a little bit, and I did development for a little bit, and I did kind of management for a little bit. But in every single one of those positions that I did consulting even for Microsoft at some point. Through all of those positions, I was always working with SQL Server in some way or another. So, it's been 18 years now. It's been a great, 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 great career. And I just went to the MVP Summit. I mean, some of you guys were there. Man, the MVP Summit was awesome because it told us, they laid it out in front of us, the future of SQL Server and what it looked like. It's now going to run on Linux. It's already running on Linux out there. So if you guys haven't seen that, you need to go take a feel the rage. Like SQL Server on Linux is going to be a huge.
Oh yeah,
huge
I think so
thing.
too. I know I've got it running on a virtual machine here on Linux, and it's pretty nice.
It is. So that's kind of the backstory on me starting with SQL Server way back when.
Excellent.
Awesome. Well, again, Argenis, thanks so much for being here, taking some time with us today.
Hey guys, thank you so much for letting me do this again. I really, really, really appreciate that you guys gave me another slot of your podcast, which is wonderful, by the way, to get some more of my opinions out there. And I know, the previous podcast actually generated a lot of controversial discussions out there on where my stance is. I actually owe some people blog posts on that to follow up on some of the points that we talked about. And they'll probably ask me about blog posts on the things that I talked about today. So I will promise, I will make that. I'll make those blog posts happen, and we'll get people really, really, really interested on testing their storage the right way.
Sounds good. We'll definitely look forward to reading those.
I think.
Sounds good. We'll definitely look forward to reading those. Wow.
Always interesting talking with Argenis.
Lots of great information there. Absolutely.
Yeah, that's right. Again, understanding what those components are so that you can ask the questions and make sure that you are testing the right things. It's interesting and I think we're all guilty of it to some point. This is just these example specific to storage, is that we kind of see what everybody else is doing and then just kind of follow the leader. But do we really understand why those processes are in place or what it is they do or don't do?
Yep. And I think some of the key factors he pointed out that really stick with me are, as the DBA, getting involved in the process earlier. I mean, getting involved to the point that you're having the discussions with a vendor prior to the purchase happening.
Sure.
And I think that is extremely important.
Yeah, before you actually need to put a database on it.
Yep.
That would just get you a few more assignments to go your way. But at the same time, you can then be known as somebody who is knowledgeable both on the storage side and on the database side. And I think that would just add value to you come review time or, when your skills are assessed by your employer.
Yep. And, another comment that jumped out at me was around always formatting your SQL data and log drives with a 64K block size, always.
Mm-hmm.
However, he did point out that one of the things that you should ask your vendor for is to ask them what they like for the block size for databases. And then if they say something besides 64K, you want to ask them why and try and get a good understanding of that. And I think part of what came out of that was oftentimes when they're doing their throughput testing, they're not testing it with databases. They're testing with other applications or just basic I/O. And they come up with other applications or just basic I/O. And they come up with a recommendation with something like 4K, which may make sense with sequential I/O for whatever tool they're using to test that.
Sure.
But it may not always make sense for the database.
No, that's right.
And I know that's one of those standards that I have always liked to check and always configure it to 64K block size. But in conversations with SAN administrators along the way, oftentimes they come back and tell you, oh, it doesn't matter. But as Argenis pointed out, it really does matter in the long run.
No, that's right. So that's a battle worth having.
Yep.
Okay, so as always, compañeros, we're interested in your feedback. You can reach out to us on Twitter. I am at Carlos L. Chacon.
And I am at SQLEMT. And don't forget, you can always use the SQL Podcast hashtag on Twitter to leave us a message or ask us a question.
That'll do it for this episode, compañeros. Thanks for tuning in, and we'll see you on the SQL Trail.
SQL Data Partners.